This video explores electrical circuits, including how components work together, how current moves through a system, and the basics of circuit design. A circuit is like a closed path that allows electricity to flow, similar to a sled track that only works when the path is complete. If there's a gap anywhere, the electricity can't move, just like a sled can't travel if the track is broken. A power source is what provides the energy that pushes electricity through the circuit. This could be a battery or a wall outlet. It creates the electrical pressure needed to make current flow. Wires are the pathways that carry the electric current through the circuit. They connect all the parts together and guide the electricity from the power source to the other components and back again. A load is anything in the circuit that uses the electrical energy. This could be a light bulb, motor, or buzzer. The load changes electrical energy into another form, like light, sound, or movement. A switch is a control device that opens or closes the circuit. When the switch is closed, electricity can flow and the circuit works. When it is open, the path is broken and electricity stops flowing. Together, these parts form a complete loop that allows electricity to travel, power devices, and perform useful work. An LED circuit is a simple electrical circuit designed to light up a light-emitting diode, LED, safely by controlling the flow of electricity. To build a basic light circuit, you need a power source like a 9V battery or a single AA battery holder, one LED, a 220 ohm resistor, recommended to protect the LED, and some jumper wires. The battery provides the electrical energy. The resistor is very important because it limits the current so the LED doesn't burn out. The LED is the load. It converts electrical energy into light. The wires connect everything together to complete the circuit. To assemble it, connect the positive side of the battery to one end of the resistor. Then connect the other end of the resistor to the long leg of the LED, the positive side, called the anode. Next, connect the short leg of the LED, the cathode, back to the negative side of the battery using a jumper wire. When the circuit is complete, electricity flows through the loop and the LED lights up. A circuit diagram is a simple drawing that shows how electrical parts are connected using symbols instead of real pictures. It helps you understand how electricity flows in a circuit. In a basic LED circuit, the power source, battery, provides energy. The positive side of the battery pushes electric current through the circuit. The current first flows through the resistor, which controls and limits the amount of electricity, so the LED is protected from too much current. After the resistor, the current flows into the LED light-emitting diode. The LED uses the electrical energy and converts it into light. The current can only pass through the LED in one direction, from the long leg, anode, to the short leg, cathode. Finally, the current returns to the negative side of the battery, completing a closed loop. This loop is important because electricity only flows when the circuit is complete, so the flow in the circuit is battery plus resistor LED battery. LEDs need a limited current to work safely. Without a resistor, too much current can flow through the LED, causing it to heat up and burn out very quickly. That's why we use a resistor in the circuit to control the current. This idea is explained using Ohm's law, V equals I x R, where V is voltage, I is current, R is resistance. We can rearrange it to find current. I equals V% R. For example, if you have a 12V battery and a 6 Greek letter omega resistor, the current would be I equals 12%, 6 equals 2.0 A. That means 2 amps of current would flow, which is far too high for a typical LED. Most LEDs only need around 10 to 20 milliamps, 0.01 to 0.02 A. So in real circuits, we use a much larger resistor, like 220 Greek letter omega, to reduce the current and protect the LED from damage. A simple way to understand basic circuit components in a different order is to think about how electricity travels through a system. Electricity starts at the battery, which is the power source. It provides the energy that pushes current through the circuit. Next, the current may pass through a switch, which controls whether electricity can continue flowing. If the switch is open, the flow stops. If it is closed, the flow continues. After that, current often goes through a resistor, which limits how much electricity can flow. This protects sensitive parts from too much current. A transistor can also be in the path or control section of a circuit. It works like a smart switch, allowing a small signal to control a larger flow of current. A capacitor may be included to temporarily store electrical energy and release it when needed, helping smooth out changes in power. Finally, the electricity reaches the LED, which is the output component. The LED uses the electrical energy and converts it into light. So in flow order you can think of it like battery, switch, resistor, transistor, capacitor. If used, LED back to battery. This shows how each part plays a role in controlling, protecting, storing, or using electrical energy in a circuit. An LED light-emitting diode has two legs, and it is very important to connect them correctly because it only works in one direction. The long leg of the LED is the positive, plus, side, called the anode. The short leg is the negative, side, called the cathode. If you look closely, the flat edge on the LED body also marks the negative side. To build the circuit, start by connecting the resistor to the positive side of the power source, like a 9V battery or AA battery pack. The resistor is important because it limits the current and protects the LED from burning out. Next, connect the other end of the resistor to the long leg, positive anode, of the LED. This ensures the current flows safely into the LED. Then connect the short leg, negative cathode, of the LED back to the negative terminal of the battery using a jumper wire. This completes the circuit loop. Now, the power on process is simple. Once all connections are secure, the circuit is still off until the loop is complete. When you connect the final wire to the negative side of the battery, the circuit becomes closed. Electricity starts flowing from the battery, through the resistor, into the LED, and back to the battery. The LED lights up instantly. If the LED does not light, check the polarity, connections, and make sure the battery is charged. A closed circuit is a complete loop that allows electricity to flow continuously from a power source through components and back again. This is essential for powering a light, such as an LED or a bulb. In a lighting circuit, the battery acts as the power source. It provides electrical energy and pushes current through the wires. When the circuit is closed, there are no gaps in the path, so electricity can move freely. The current flows from the positive terminal of the battery, through the connecting wires, and into the light source, LED or bulb. If it is an LED, the electricity must go through the correct direction, positive, anode, to negative, cathode. Often a resistor is included in the path to limit current and protect the light from damage. After passing through the light, the electricity continues through the wires and returns to the negative terminal of the battery, completing the loop. This complete loop is called a closed circuit, and it is the only condition where the light will turn on. If the circuit is broken anywhere, like an open switch or a loose wire, electricity stops flowing and the light turns off. So, a closed circuit for powering a light is simply a continuous path. Battery wires light back to battery. An open circuit is a circuit that has a break or gap in the path, which stops electricity from flowing. Because the loop is not complete, current cannot travel from the power source to the light, so the light stays off. In a normal lighting circuit, electricity is supposed to flow from the positive terminal of the battery, through wires and components like a resistor and LED, and then return to the negative terminal of the battery. This complete loop is called a closed circuit, and it is what allows the light to turn on. However, in an open circuit, somewhere in this path is disconnected. This could be a switch in the off position, a loose wire, a broken connection, or a gap between components. Because of this break, electrons cannot move all the way around the circuit. For example, if you have an LED circuit, but the wire is not connected to the battery's negative terminal, the circuit is open. Even if the battery is working and the LED is connected correctly, the light will not turn on because the energy has no complete path. So in simple terms, closed circuit equals complete loop equals light on, open circuit equals broken loop equals light off. An open circuit is actually useful in real life because switches create open circuits when you turn lights off, stopping electricity safely. This video covers the basics of electrical circuits, including how current flows through a complete loop, and the difference between open and closed circuits. It explains how a battery acts as a power source, how wires carry electricity, and how components like resistors, switches, and LEDs work together. You will also learn how an LED lights up safely using a resistor, why correct polarity matters, and how electricity must travel from the positive terminal of the battery through the circuit and back to the negative terminal. Finally, the video shows how breaking the path creates an open circuit, stopping current and turning the light off.